So today's topic is still chapter 12 notes, but it is about concentration of units. Concentration is of a solution is amount of solute present in a given quantity of solvent or solution. Basically, it is a concentration would be, say, for instance, I'm making tea and I drink a lot of tea. Sometimes I like it. Some people say strong, and some people like it. Some people say weak. In terms of tea, you could say it's a strong tea. That means you steep the tea leaves for quite a while. Okay. A weak tea would be something dilute, or you did not steep the tea very long, or you just didn't use much tea leaves. In chemistry, we don't just say it's strong or weak. We say that it's highly concentrated or it has a low concentration. Concentration is amount of solute. So the solute, the example I talked about would be like tea in a given quantity of solvent, which would be water or solution. Okay, so once you mix the tea leaves in water, it makes tea is a solution. So how we measure it is there's four main ways. One is called percent by mass. So we're going to go through each of the four different ones. One is called percent by mass. Percent by mass, the mathematical definitions right here. Percent by mass is equal to the mass of the solute divided by the mass of solute and the mass of solvent times 100, because we're talking about percents here. Or the mass of solute plus solvent is the mass of solution total. So mass of solute plus solvent, which is mass of solution. So mass of solute divided by mass of solution times 100. Let me just do a example of that. Let's just say you're dissolving something simple. Let's just say salt, sodium chloride. Okay, you're dissolving 2 grams of salt in, I don't know, maybe say 250 milliliters of water. Or actually, since this is mass, let's stick with grams. Let's say you have 2 grams of salt in 250 grams of water. If I said milliliters, you would have to change your milliliters into its mass into grams. I mean, you probably need to know the density. Well, actually, I do know the density of water, which is just 1. But so, okay, so like we just said, we're dissolving 2 grams of salt, sodium chloride is salt, in 250 grams of water. I want to know the percent by mass. Well, there's 2 parts here. There's a solute and a solvent. And we talked about earlier, when you say something is dissolving in something, X is dissolved in Y. X is your solute, Y is your solvent. When we say we're dissolving 250 grams of salt in 2 grams of salt in 250 grams of water, what is the percent by mass? Okay, 2 grams of sodium chloride salt is dissolved in 250 grams of water. What's the percent by mass? Well, first of all, you should know that this is my solute, my salt. And water, my 250 grams of water, is my solvent. Well, the equation for percent by mass is mass of solute divided by mass of solute and the mass of solvent times 100. So here is my mass. Is already, I left, these are already in grams. So my mass of my solute is 2 grams divided by my mass of my solvent is 250 grams. So my percent by mass of, in this case, sodium chloride, would be my mass of sodium chloride, which is 2 grams, divided by the mass of the sodium chloride plus the mass of the water times 100. Okay, I didn't write the equation, but here it is. Percent by mass is mass of the solute, which is the salt, divided by the mass of the solute, which is salt, plus the mass of the solvent, which is the water. So I didn't write the equation, but there it is. And so from here, I just need a calculator. Grab a calculator. So what is that? 2 divided by 2 plus 250. Remember, times 100 because we're dealing with percents. So what is that? That's not even 1%. 0.793% salt. And it's not 1% because, well, again, it's only 2 grams of salt in more than 250 grams of water. So, of course, that's less than 1%, 0.793%. This is just my made-up example. Okay, so that is how we do an example of percent by mass. That's not the only way we measure concentration. Another common one is called mole fraction. And what is that definition? Mole fraction, the symbol is X. I didn't make up the symbol, but the symbol is X. Mole fraction X is equal to the moles of A. So the mole fraction of A, okay? You don't want to say mole fraction of X because X is mole fraction. Mole fraction is A is equal to moles of A divided by the sum of moles of all components. Basically, the moles of everything else. So moles fraction of A is equal to moles of A divided by the sum of moles of the total. So if I want to figure out the mole fraction, what is the mole fraction of salt in that problem? Okay, I'm just drawing an arrow instead of, okay, when you have 2 grams of salt divided by 250 grams, or mixed in 250 grams of water. What is a mole fraction? Well, mole fraction of sodium chloride will equal to number of moles, N stands for moles, moles of salt divided by the moles total. So what are the total stuff? It's going to be the moles, N stands for moles, moles of sodium chloride, and the moles of water. I only have 2 things, salt and water. So if I'm trying to find the mole fraction of salt, find the number of moles of salt divided by moles of everything, okay, all components. We're usually going to only talk about 2 things, like in this case, salt dissolved in water. Yes, you have salt and sugar and something else and whatever, all dissolved in water. But we're going to keep it simple, just salt dissolved in water, okay? Well, to do this, we need to convert these grams into moles. It's been a little while converting grams to moles, but converting grams to moles. So converting grams to moles, I have to somehow convert my 2 grams, if it'll fit in this paper, yeah. 2 grams of sodium chloride into moles. Change grams, that's 2.00. I put 2.0 because this rule is a sig figs. Let's not worry about sig figs right now. But 2 grams of salt. How do we convert to moles again? What we need to do to change grams to moles, this is from last semester, is we have to divide by the molar mass. So we need to find the molar mass. Molar mass is adding up sodium on the periodic table plus chlorine on the periodic table. Sodium was 20, I don't have a periodic table in front of me to show you, but sodium on the periodic table is 22.99. Chlorine is 35.45 on the periodic table. That adds up to 58.44. 1 mole of sodium chloride weighs 58.44 grams. And again, I get that from that the molar mass of sodium in sodium chloride is 22.99. The molar mass of chlorine is 35.45. And so that adds up to 58.44. Grams and grams will cancel. Now I have moles of salt. I don't know what 2 divided by 58.44 is, but I have a calculator. 2 divided by 58.44 is 0.0342. 0.0342 moles of salt. So the moles of salt, 0.0342. Let me plug that in. Moles of salt, 0.0342. The salt, 0.0342. I need to find one more thing, the moles of water. So to find the moles of water, how much water did I have anyway? 250 grams of water. 250 grams of H2O. Change that to moles, meaning I have to find a molar mass of water. The molar mass of water would be how much does 2 moles of hydrogen weigh and 1 mole of oxygen weigh. Hydrogen on periodic table, 1.01. Oxygen on periodic table, 15.9994. Okay, or 16. Okay. I just know that because I've done this many times. I looked it up in the periodic table, but you have to look up hydrogen on periodic table 1.01, and oxygen actually about 16. So that adds up to 18.02 grams. Okay. So grams will cancel. 250 divided by 18.02, and I don't know what that is. 250 divided by 18.02 is 13.87. 13.87 moles of water. Okay, so moles of water, 13.87. So plug that all in a calculator, and I will have the mole fraction, the moles of salt divided by moles of everything total, which is 0.0342 plus 13.87. Okay, it's not going to be a big number. I don't know what it is, but let me type that on a calculator. 0.0342 divided by, in parentheses, 0.0342 plus 13.87. 0.0024, around 6. Okay, so my mole fraction would be that. We don't multiply this by 100, unlike the last one, because that one was percent. Yes, percent-wise, it would be 0.246% salt in moles, but we don't. These are not technically percents. Okay, so that is mole fraction. Okay, one of our 2 main concentration units. We're not done. As I said, there's 4 units of concentrations. Next big one, we've actually seen before. You've seen this before. It's molarity. Molarity is equal to, what was it again? Moles of solute divided by liters of solution. Moles of solute divided by liters of solution. And so let's do an example of that using the exact same one. I'm just going to use a paper to cover up so I have space. Let's say I'm trying to find a molarity, but I do have to convert one thing. So, okay, now the question is, what's the molarity of the solution? I know I'm not writing proper grammar, but whatever, you get the point. What's the molarity of the solution? Okay, if you had 2 grams of salt in 250 grams of water. First of all, the equation is molarity, capital M, is equal to moles of solute divided by the liters of solution. I wrote it down this time. Okay, I'm going to have to mention one thing for water. If you didn't remember, and this only technically applies to water, 1 gram of water is 1 milliliter of water. Why? The density of water is 1. The density of water is 1. 1 gram of water, there's 1 gram per milliliter. Okay? So 1 gram of water is a milliliter of water. In other words, the number of milliliters there is, you have 250 grams or 250 milliliters of water. I'll write that down here. 250 milliliters of water in this case. Why do I not just plug it in? Well, because technically this is grams and that's liters. Those are two different things. 1 grams, 1 liters. It just so happens that for water, 1 gram of water weighs 1 milliliter. If it were not water, you can't just switch it like that. You would need to know its density. And then use density. Density is equal to mass over volume, and then solve for it. But water's density just so happens to be 1. So I actually know the, oh, there's actually one more thing. Technically, okay. There's one, technically this is not going to be exactly correct, but let's just say the entire solution is 250 milliliters. Because technically once you add 2 grams of water into 250 grams, 2 grams of salt in 250 grams of water, the volume is not going to be 250 milliliters or 0.25 liters. Because technically once you add a little bit of something in some salt, increase the volume a little bit, but for the point of this question, I'm just going to ignore that for right now. Okay, but technically I would need to have a little bit more information. So maybe I should have changed the question, said, okay, yeah, 250 grams of solution in this case. Or 250 milliliters of solution. That's okay. It's just the point of this. So technically it's not 100% accurate, but that's fine for now. Okay, next thing, moles of solute. My solute is 2 grams of salt. We already did that. What was it? It's right down here. 2 grams of salt is 0.0342 moles of salt. So I'm just going to use this. That's why I was using the same number, so I didn't have to resolve this. 2 grams of salt is 0.0342 moles of salt. So 2 grams, so my moles of salt is 0.0342. 0.0342? Yeah, 0.0342 moles of salt. Sodium chloride, that's a Cl. So what's the molarity now? It'll be 0.0342 divided by 0.25. 0.0342 divided by 0.25 is 0.137, because technically 3 sig figs. 0.137, the unit's molars. Molarity, molars of sodium chloride. 0.137 molars of sodium chloride, that is 0.137. You can also write as moles per liters. They mean the same thing. 0.137 molars of sodium chloride, 0.137 moles per liter sodium chloride, they mean the same thing. Molarity, capital M, is moles per liter. They're interchangeable. So you could write it either way. Okay, and the last, 4th way of measuring concentration. Now, in case you're wondering, oh, why so many different units of concentration? Well, why do we have all these different other units like cups and milliliters or Celsius and Fahrenheit and Kelvins? They're just different units. We use them in different ways. Why pounds versus kilograms versus ounces? Well, we use different things in different ways. And it's not that one is better than another. We can convert between them. You can convert between Celsius and Fahrenheit. And there's an equation for that. We will be eventually, after, not today or not in this one, be converting between molarity and molality. It's actually the next slide is an example. Not right now, but it's just a different unit, okay? And we use them in just, some people prefer kilograms, and some people prefer pounds. It's not necessarily one is better than another, okay? So we have one more called molality. Molality is lowercase m. Notice molarity, capital M. Molality, lowercase m. Molality is moles of solute divided by mass of solvent in kilograms. Notice the big difference. That's liters of solution. This is the mass of just a solvent. This is solute plus solvent is the solution. This is just the solvent in kilograms. And so, let's get back to this example again. Now, let's say, same problem. I'm trying to find the molality this time. So, what's the molality? Of sodium chloride in the solution, okay? When I have 2 grams of salt dissolved in 250 grams of water. So molality, lowercase m, is defined as moles of solute divided by kilograms of solvent. Moles of solute divided by kilograms of solvent. Moles of solute, well, it's the same solute. In this case, 0.0342 moles. Technically, I had to convert the grams into moles, but we've already done that, so I don't want to do that again. Convert the grams to moles. 0.0342 moles of salt. Divided by kilograms of solvent. What's my solvent? 250 grams of water. It's already grams. Well, grams is technically kilograms, but that's easy. Grams of kilograms divide by 1,000. So it's 0.0342 moles divided by 0.250 liters. Oh, sorry, kilograms. The reason why is that because I was copying that. These are the same numbers. So I don't really need to plug in a calculator. That is 0.137 lowercase m for molality. Capital M is molarity. So 0.137 lowercase m, and we call this thing molos. Molos. 0.137 moles of sodium chloride, 0.137 molars, molars for molarity, molos for molality. Okay, so in this case, it's pretty much the same. Technically, molarity this is not necessarily the most accurate because when I was making this problem up, I realized, oops, technically this is liters of solution, and I just put the solvent. Solution is solute plus solvent, and I was kind of ignoring the volume of the sodium chloride. But technically I shouldn't have, but I don't know the density of sodium chloride. I would have to have looked that up to factor that in, but I also know the volume of sodium chloride is not that big, whatever it is. Okay, 2 grams of salt is not very big. So technically, this would have been a little bit smaller. I would have been a little bit more accurate with these kind of numbers with future problems. Anyway, so that is the basics of our 4 different units of concentration. We have molarity, capital M, moles per liter, also called, when we say it's molars. Molality, lowercase m, we call them molos. So again, we could say 0.137 molars or 0.137 molos, molars, molos. And we also have other units, percent by mass and mole fraction. Okay, so that's it for right now. Next time we'll be talking about how to convert between some of these units.